Welcome. In this video, we'll be looking at percent composition, what it is, how we use it, and we'll go over a practice problem at the end of the video. Alright, so let's start off with a quick definition. Percent composition can be defined as the percent by mass of each element that constitutes a compound. Now that may be a bit wordy, it may be a bit tricky to visualize, but the way that I like to think about it is how much each element is responsible for the compound. The way the compound turns out, the mass of the compound. And you'll see what I mean once we get into the chemistry part of it, but for now, I like to start off with a bit of a non-chemistry example. So let's say that we're going grocery shopping and you decide to pick up an orange over here. This is supposed to be an orange, and this is a watermelon. All right, and these values here aren't accurate, but they're simply for the example. And say we're trying to find the percent composition of the groceries in this bag. Right, so we can the analogy would be that the entire bag is the molecule, while the orange is an atom and the watermelon is another element. Sorry, the orange is an element and the watermelon is an element. Right, so let's start off by determining how much the overall molecule weighs, or the overall bag. From that value, we can get the value of each individual grocery item and divide that and get a percentage. So the overall mass of the overall bag would be about 180 grams, because if you add these values, let me change the color of my marker. If you add these values, you're going to get 180 grams. All right, so let's find the percent composition of the orange first. So the orange, right? So you know that the overall mass of the bag is 180 grams. So we want to find the percent by mass, how much of the mass the orange contributes to it. And it's, as we can see, the orange has 30 grams. 30 grams. And since we're trying to determine a percent value, we need to multiply this by 100%. All right, and we can set the same thing at the bottom over here for the watermelon. So watermelon, and we have 150 grams up here because that's the weight of the watermelon itself, and as we determined earlier, the overall weight of the bag is 180 grams. So from this, we can see how much of the overall weight of the bag the watermelon contributes to. And since we're determining a percentage, we need to multiply by 100%. All right. So now we can determine the values if we just put it into a calculator. And roughly, you will get 16.7% for the orange. And for the watermelon, you'll get about 83.3%. And just to make sure that the values make sense, you can add them up together, and they should be very close to 100%. All right. So this is just a very simplistic example. This is like a real world kind of way of thinking about it. And this can be applied to the chemistry part of it as well. And some textbooks will give you kind of a formula like this. It's just the same thing we did over here. It's the molar mass of an element divided by the molar mass of the entire compound multiplied by 100%, and that will give you the percent composition. Again, percent composition kind of refers to how much the molar mass of A is responsible for the molar mass of the entire compound. That's a really cool way of thinking about it, and that will help you understand what kind it is. All right, so let's move on to a practice problem. And here, we're trying to determine the percent composition of acetic acid. And I wrote out the formula for acetic acid here in these fancy colors. And what we need to do first, as we can tell by the formula here, or just by common sense, if we go back to our original example, is that we need to determine the overall mass of the compound. Right? And this ties back to our previous video when we looked at determining the molar mass of compounds. What we need to do is get the molar mass of each of the constituent elements, add them up, and we get the overall compound. So we have carbon atoms, so say we have carbon atoms, and each carbon atom is about 12.01 grams, and there's 2 of them, so multiply by 2, and that's going to give you about 24.02. All right, there are 4 hydrogen atoms. The formula for acetic acid is written a bit differently due to the functional groups, so we have to count this hydrogen as well. So it's going to be 1.01 grams multiplied by 4. That's going to give you about 4.04. And then finally, we have 2 oxygens. And oxygens are about 15.99. I'm going to make it 16 for the purpose of simplicity. And this is going to be about 32.00. right? So you're going to get 0.06, 4 plus 4 is 8, plus 2 is 0, carry over the 1, and then you get 60.06 grams. Approximately, that should be the overall molar mass of this entire compound. All right, so that's how you determine the molar mass of the entire compound. When it comes to percent composition, typically you'll be asked to determine the percent composition of each of the elements of the compound. So we can use this value to determine the percent composition of each of the elements, and we have most of the work done for us. So let's do it for carbon here. So we'll do carbon. So we have 24.02 grams of carbon because there's 2 carbons, and we did that calculation earlier. And we're going to divide that by about 60.06 grams, which is the overall molar mass, and multiply that by 100 to get percent. Right? And this is similar to the formula, the quote-unquote formula we have over here. And what we're going to do here is do this in our calculator, and you should get in a value about 40%. All right, so now let's do it for the other elements. You do the same thing, same process. So we have about hydrogen here, and we determined that the overall mass of the 4 hydrogens is about 4.04 grams. So we're going to get 4.04 grams, divide that by about 60.06 grams, multiply by 100% to get a percent yield, and then we're going to get about 6.66%. Should be what we get there. And finally, we have oxygen. Right? And oxygen, we determined that's going to be about 32 grams. So 32 grams of oxygen divided by 60.06, multiplied by 100%, and that should give you 53% in that ballpark. And just to make sure we did this all correctly, we can add these values up. 53 plus 6.666 is about, it's about 60%, and that's going to give you plus 40%, which is about 100%. All right, so that's determining the percent composition of acetic acid. All right, so in this video, we looked at percent composition, what it is. We looked at an example at the grocery store. We looked at the general formula of how to determine the percent composition, and we did a practice problem where we determined the percent composition of acetic acid. If this video helped you, please click the like button, consider subscribing to the channel, and hopefully we'll see you next time.